Hi, my name is Billy Clay Myers, and I'm here to talk to you about ExpressRoute. You may be asking yourself, what is it? Why should I use it? And what are some architecture and security considerations I should make when using it? Hopefully today we can demystify some of the things surrounding ExpressRoute. First, ExpressRoute is not magic, and you can and should apply your on-premises networking knowledge when thinking about and designing for ExpressRoute. At its simplest, ExpressRoute should be thought of as connecting an Ethernet cable from one switch to another between two LANs that previously used a VPN tunnel. Suddenly, the latency drops between PCs on both networks, and bandwidth goes up. Now, before we go any further, let's talk about VNets in Azure. A VNet is simply a virtual network, or software-defined network. If you've ever configured Hyper-V or VMware, you have used the default and maybe even created a software-defined network. The same considerations for address space, network segmentation, subnets, etc. that would apply on-premises apply in Azure. The reason I bring up VNets here is that a VNet is ultimately what you're going to be connecting to in Azure. It is synonymous with a LAN segment in your on-premises network. Now, back to ExpressRoute. ExpressRoute is a private connection from your network to a Microsoft peering location, which is a fancy way of saying a supported termination point within the Microsoft Cloud Network. A list of peering locations, as well as connectivity providers, can be reviewed at the link at the bottom of the slide. Each ExpressRoute circuit consists of two connections to two Microsoft Enterprise Edge routers from your chosen provider. Note, there is no redundancy requirement on the physical connection between you and your chosen partner, but Microsoft does require redundant connections from your partner to the Microsoft Edge as shown here. At this point, you might be thinking, why don't I just use a VPN? And while there are certainly appropriate use cases for both point-to-site VPN and site-to-site VPN within Azure, in an enterprise setting, ExpressRoute has key advantages. It is also important to note that site-to-site VPN has a maximum speed of 1.2 gigabits per second. ExpressRoute is a private connection. This means we gain reliability, faster speeds, lower latency, and higher security. All the same benefits you would reap in my example of removing a VPN and connecting an Ethernet cable between two switches. So once you've decided to use ExpressRoute, what are some of the considerations? First up is bandwidth. ExpressRoute is available starting at 50 megabits per second all the way up to 10 gigabits per second. This will depend on the chosen provider, of course. Note, you can increase the circuit bandwidth on a best effort basis without tearing down the ExpressRoute connection first, should you determine that you need more bandwidth, provided that your chosen provider supports the next higher bandwidth level. Once you decide on a speed, you need to decide on the billing model. That is, unlimited data or metered data, and finally, whether you want ExpressRoute Premium. Unlimited is exactly what it says. There is no charge for inbound or outbound data, regardless of the size or quantity. Metered provides unlimited data into Azure, whether it be backups to Azure Blob Storage, SQL Server replication, or any other type of data that you might move into Azure from your on-premises network. Transferring any data out of Azure, however, results in a charge. As of January 18, 2018, that's 0.025 cents per gigabyte for Zone 1, 0.05 cents per gigabyte for Zone 2, and 0.14 cents per gigabyte for Zone 3. Now the ExpressRoute Premium option, which is available whether you pick metered or unlimited, increases your route limits to 10,000 from 4,000, provides global connectivity to services in any region other than Azure China, Azure Germany, and Azure Government Cloud. Now what this means is that traffic between your peering point and the remote Azure data center will traverse the Microsoft backbone, providing lower latency and better security. Additionally, it increases the number of VNet links per ExpressRoute circuit based on the chosen bandwidth. This will make more sense once we get to the architecture discussion. Once you've decided to go ExpressRoute and have begun your discussion with your service provider, Do not establish the ExpressRoute circuit in the Azure portal via Azure CLI or PowerShell until your chosen provider tells you they are ready. As soon as you perform this step in Azure, whether or not the ExpressRoute circuit exists, billing will begin. Once you have your circuit in place and established, you'll need to set up peering. Peering is how you connect to the various services available in Azure from your on-premises network. There are 3 types of peering that can be enabled on your ExpressRoute circuit. Azure Private Peering, which provides connectivity to virtual networks, including the virtual machines within those virtual networks, as well as any other resources attached to the virtual network. Azure Public Peering, which provides access to public services such as Power BI, Dynamics 365 for finance and operations, and most of the public Azure services, with the following exceptions: CDN, Visual Studio Team Services load testing, multi-factor authentication, and Traffic Manager. What this means is that connections to these public Azure services will be provided via ExpressRoute when initiated from the on-premises network. This ensures that you get a low latency connection to those resources. Finally, we have Microsoft Peering. This connects your on-premises network to Office 365 and Dynamics 365 customer engagement applications, such as Dynamics 365 for sales, Dynamics 365 for customer service, Dynamics 365 for field service, and Dynamics 365 for project service. Again, allowing for a low latency direct connection from your on-premises LAN to these Microsoft hosted services. You can filter services that are available across your Microsoft peering connection. After you've established peering, you will need to make sure that your on-premises routers are configured to pass traffic over the ExpressRoute circuit. The link at the bottom of this slide will take you to an article with some samples. These are just samples and must not be used as is. Your network team should use these samples as guidance for configuring routes that are appropriate for your network and security needs. When designing VNets that you know will be peered or that might be peered in the future, make sure to use non-overlapping address space. If you plan to never peer a VNet, such as dev test or even something in production that's never going to be connected out to another service, you can overlap address space all you want. You could use 192.168.0.0 with a /24 subnet all over the place, no problem. But if you plan to peer them, they must be in separate address spaces. On to ExpressRoute architecture. Hub-spoke, and forced routing. What I plan to talk about here are some of the common questions that I get asked when discussing ExpressRoute with enterprise customers. At this point, you have your ExpressRoute connection stood up, and it would be perfectly acceptable to connect one VNet to your ExpressRoute and just start loading resources into that VNet as if you were plugging computers into a stacked set of switches. Or link a VNet that already has a bunch of resources in it. However, that would not be the best for performance, security, or any other number of network design best practices. What most people do is a form of a hub and spoke network, which is what we're going to discuss now. You can design your hub and spoke ExpressRoute in a couple of ways, but they basically boil down to 2 fundamental patterns, no matter how elaborate you might get. The first is by making the ExpressRoute gateway the hub and connecting your VNets to it. I'll call this Hub-Spoke version 1. In this configuration, every VNet is peered or connected to the ExpressRoute circuit, and they can all communicate with each other. This communication could be locked down within SGs, but by default, the machines in the IT VNet can access the machines in the Dev Test VNet and the Prod VNet, and vice versa. This connectivity is possible because of the routing that is automatically put in place by Azure when peering is established. Now, I cannot stress this enough. In this configuration, every VNet that is peered or connected to the ExpressRoute circuit can communicate with each other. Now, this is a very important distinction between the 2 versions of hub and spoke I'm going to show you. Make sure that you are completely aware that if you just connect these VNets to the ExpressRoute circuit in a peering fashion, Everything in the IT VNet in this example can talk to everything in the dev test VNet, everything in the prod VNet, and everything in the DR setup VNet. To bring this concept to the on-premises world, imagine that each of the 4 VNets you see here were actually rooms containing computers connected to layer 3 network switches. Also imagine that between these rooms, in the hall, you have a layer 3 switch that connects back to your main network. Plugging a network cable from each room's switch to the hall switch would be synonymous with peering to the ExpressRoute gateway. The difference is that in the case of the ExpressRoute, the required routing is automatically enabled and configured, whereas on premise, you would have to configure the routing on your layer 3 network device. When using the ExpressRoute gateway as the hub, as in example V1 that we were just showing, there is a limit to the total number of VNets that can be peered directly to the ExpressRoute circuit. The chart on the screen here shows you that without choosing the premium add-on, no matter the speed, 10 is the limit. If you choose the premium add-on, then based on speed, you gain the ability to peer different numbers of VNets directly to the ExpressRoute circuit. One additional note I want to make here. Any traffic between VNets peered directly to the ExpressRoute circuit incurs no charge. What I mean is that in the previous example, if our IT VNet talks to our dev test VNet and transfers 4 terabytes of data, there is no charge for that transfer between VNets that are peered directly to the ExpressRoute circuit. Now, if that traffic had gone back on premise and we had chosen a metered connection, we would be charged. One additional benefit / side effect that I want to discuss of Hub and Spoke version 1, where we peer directly to the ExpressRoute circuit, is that traffic between those VNets that are peered directly to the circuit incurs no additional cost. So if you moved 4 terabytes of data from the IT VNet to the dev test VNet, because they are all connected directly to the ExpressRoute circuit, it's a side effect, but it is a benefit of peering in this manner. The next option, which we'll call HubSpoke version 2, is to make the hub of your network a VNet, which is peered to ExpressRoute, and all other VNets peer to that hub VNet. With this hub and spoke configuration, the automatic routing that is put in place results in a different traffic pattern than peering VNets directly to the ExpressRoute circuit. To use this diagram as an example, resources in the Spoke 1 VNet can communicate with the hub VNet, but not resources in the Spoke 2 VNet. In the same manner, resources in the Spoke 2 VNet can communicate with the hub VNet, but not resources in the Spoke 1 VNet. This provides clear segmentation out of the gate and allows access to shared resources such as DNS that might be located in the hub VNet. There are a few items to consider with this configuration. First, VNet peering incurs a 0.01 cent per gigabyte charge for data that traverses the peering connection. Additionally, there is a limit to the total number of private peering connections that are possible to a given VNet, 10 by default. The latency of traffic between resources in peered VNets is the same as if the resources were in the same VNet. So if I'm in Spoke 1 VNet and my 2 VMs are talking to one another, they incur the same amount of latency as if those VMs are communicating to the DNS VM in the hub VNet. The traffic that is flowing between the VNets is private. It traverses the Microsoft backbone as if it was within the same VNet. No public internet, gateways, or encryption is required for this traffic. Now, that's not to say that your own security requirements don't say that it must be encrypted or somehow other inspected. Now, peering between VNets in the same region is generally available, while peering between regions is in public preview for certain regions, and this is as of January the 18th, 2018. Also, virtual networks, or VNets, can be peered between different subscriptions. What you could do is you could set up one subscription for central IT that contains the hub VNet. You set up your DNS, you set up your inspection NVAs, you set up any other things that are central, core to the needs of all of your subscriptions. You set all that up in the hub VNet within the infrastructure or central IT subscription. Then you have the subscription for dev test, or maybe some division within your company, those separate subscriptions can have VNets that peer into the central IT subscription to create this hub-spoke network. All of the VNets do not have to reside in the same subscription. One last thing, going back to the address space discussion we had in the beginning about not overlapping address space. If you have a virtual network and you determine that you have a need to add or shrink address space within that virtual network, and it is peered to another virtual network, you will have to remove the peering connection before being allowed to modify the address space. Once the address space has been modified and is how you want it, you can re-peer that virtual network with the other networks that it previously was peered with. But it does require downtime to modify that address space. Now, as we talked about, in this sort of hub-spoke configuration where we're peering VNet, the two individual VNets peered to the hub can't communicate with one another. In order to enable communication, you could do a couple of things. You could peer the two VNets together. So I could peer spoke 1 to spoke 2, as well as having them peered to the hub. Or the recommended way is to set up an NVA or network virtual appliance in the hub VNet that acts as a router and leverage UDRs or user-defined routes in each of the spoke VNets connected through the router NVA to allow communication. To further expand on the VNet spoke hub scenario, as I discussed, there is a limitation to the number of VNets that can be peered to one another. So the limitation would be that your hub VNet could only have 10 spokes. Well, the way around that is with hub spoke, where in actuality, your first layer of spokes are really hubs that have spokes coming off of them, as in this diagram. As you can see, we have the hub VNet. Then we have spoke hub 1 and spoke hub 2, which are the spokes off of the hub VNet. You can see that each of them is in of itself a hub with resultant spokes. So this gets us past the limitation of peering 10 VNets to a single VNet. Now I did mention that's 10 by default. It can be as high as 50. If you have a need for more than 10, you can contact support and support can open up a ticket. This is done on a case-by-case basis. Can't guarantee that it will be allowed, but you can open up a ticket to request that the limit on VNet peering be raised from 10 to some other number. So up until this point, we've been talking about inbound traffic, things coming from on-premises network to Azure or from Azure to Azure through the hubs, through the spokes. But what I want to talk about now is something that's going to sort of lead into our next discussion about security, and that is outbound traffic from Azure. By default, when you create a VM, there is a route that allows for public access to the internet from that VM. So unless you remove that route, if your VM needs to connect to Windows Update, it needs to connect to some other update service because of some software installed, or you open a web browser, it is going to connect directly to the public internet. It's not going to come on premise. It's not going to be inspected. You can force the traffic from Azure back on premises through ExpressRoute and out your internet connection. Now realize that this will add load to your on-premises network infrastructure and whatever you have in place to manage and inspect traffic bound for the internet. But it does make sure that everything in Azure is forced back through your inspection point for access to the internet. Another way that you could handle your outbound traffic is by configuring a similar DMZ to what you have on premise. What I mean by that is you could set up network virtual appliances to provide the same level of inspection that you use on premises. You can configure them in the same way. You can configure them to drop their logging back on premises so that you can aggregate it, search it, however you may be using that. But using user-defined routes, you can ensure that traffic passes through your virtual DMZ prior to reaching the internet. Now, this does require that you remove that default route that allows a VM out to the world, but If you do that and you set up the UDRs, you can force inspection even within Azure itself. This does take the load off of your on-premises network and allows those VMs to connect directly out. You can additionally leverage this for inbound traffic. So if you have VMs that host websites, you can set them up behind virtual network appliances, behind load balancers, and force traffic to them via UDRs, ensuring that all inbound traffic is inspected in the same manner as if it was in your on-premises data center. This brings us to ExpressRoute and security. What do I get by default, and what can I add? The first question that most people ask is the ExpressRoute circuit encrypted? The answer to that is no, not by itself. The circuit that is created when you first enable private peering or public peering or Microsoft peering is private and dedicated to you, but does not natively encrypt any traffic. To secure the connection, you have a lot of options. For maximum security between your on-premises network and Azure, add network security appliances between the on-premises network and the provider edge routers to restrict inbound traffic from Azure VNets, as shown in this diagram. Another option is to use an NVA or network virtual appliance in Azure connected to an on-premises device. Implementing an NVA to provide an encrypted connection would allow for more control and inspection. In this example, which is from F5 and the link to it's down at the bottom. And note, F5 is not the only answer here. There are a bunch of NVAs available in the marketplace and you can examine those through the portal. But in this example, if you were already leveraging F5 Big IP on premises, you could configure a Big IP, whether virtual or physical, on premises and deploy an F5 NVA within Azure and create an encrypted tunnel between those two devices across ExpressRoute. In order to force all traffic through the NVA before traversing the ExpressRoute connection, you'll need to make sure that you have configured the appropriate routes both on premises and in Azure. A third option is to configure a site-to-site VPN over ExpressRoute with Microsoft peering enabled, and the link to this document is at the bottom of this slide as well. This results in a connection that is secured by an IPsec/IKE, IKE v1 or IKE v2 VPN tunnel. Now, to utilize this tunnel, you'll again need to ensure that the routing is configured properly on premises to force the traffic through the VPN device in your on-premises network. You'll also need to make sure that traffic is configured on the Azure side to flow back through the VPN as well. Now, let's say that you're good with the ExpressRoute connection being private and you're not worried about encryption. You could still leverage an NVA or network virtual appliance in the hub VNet to provide inspection and monitoring of traffic without forcing encryption across ExpressRoute. Now again, this would be up to each organization and the requirements that are in place for security. Now, one thing I want to do to sort of bring this all back together is if we go back to Hub and Spoke v1, where all of the VNets are peered directly to the ExpressRoute circuit. If we're in that scenario and we want to enable, say, an encrypted connection with NVAs, you would need to deploy an NVA into each of the VNets that is peered, as there is no central place for that NVA to go when we're peered directly to the ExpressRoute circuit. So each VNet would get its own NVA. They would all have connections back on premises. Same thing with the VPN. If you're peered directly, each one of those VNets would need a virtual private network gateway in Azure, and you'd set all that back up to on premises. Now, while that is doable, you do have to deploy quite a few more devices than if you leverage a single hub VNet and do everything off of that with VNet peering. I just wanted you to be aware of that it is doable, but you are going to end up deploying however many NVAs you have VNets. To additionally talk about Azure security directly, in the realm of security, Microsoft offers over 40 certifications and attestations, which is the most comprehensive of any cloud service provider. A few of them are listed here: the ISO certifications, ITAR, HIPAA, IRS. You can review those certifications and additional certifications at the Trust Center, the link of which is at the bottom of the slide. At the end of the day, security is one of those things that is unique for each customer based on the workloads being deployed, as well as internal security policies and potentially other factors within your organization. This is a discussion that you need to have in your organization, and you need to include security at every step of your cloud journey to ensure that any and all security concerns are being addressed. As a starting point, you can find Microsoft's best practices at the link at the bottom of this slide. There you'll find the flowchart that's displayed on the screen that has decision points and points you at specific examples that you can read to learn how Microsoft would suggest that you configure your security. Again, security is unique for each organization. Take these best practices, go back to your network team, work with them to determine what is the appropriate security for you. Because what's appropriate for you may not be good enough for the next guy, or may be too stringent for the next guy. Each person, each organization needs to determine this on their own. Thank you for watching. I hope that this video has helped to demystify some of what Azure ExpressRoute is, what it can do, and some of the architecture and security concerns you might need to take into account when designing your ExpressRoute circuit. As you may have noted, at the bottom of each of these slides, there's been a link. That link will take you back to the Microsoft website to the documentation directly relating to what's on that slide. You can read all of the information there, and I suggest that you do read all of the information there.